Welcome to the DIY Honda Garage channel. DTC P1188 refers to a malfunction in the fuel temperature sensor circuit, specifically indicating high voltage levels. This diagnostic trouble code can lead to performance issues in the engine and affect fuel consumption. The FTT sensor is responsible for measuring the fuel temperature, which is crucial for the engine control unit, ECU, to optimize fuel delivery and emissions. Its location is typically found near the fuel line or within the fuel tank assembly, making it essential for accurate fuel management. When this code is triggered, it's vital to perform a thorough troubleshooting process to identify and resolve the underlying issues related to the sensor or its wiring. Always ensure to check the vehicle's freeze frame data before initiating troubleshooting, as it provides valuable insights into the conditions leading to the error. DTC P1188 indicates a high voltage issue within the fuel temperature sensor, FTT circuit. The FTT sensor is integral in measuring the temperature of the fuel to assist the powertrain control module, PCM, in managing fuel injection and combustion efficiency. Its proper functionality is crucial for optimal engine performance. The sensor can be found in the vicinity of the fuel line or within the fuel tank, directly measuring fuel temperature. Electrical issues or faults in the FTT sensor circuit can cause the PCM to receive incorrect readings, leading to adjustments that can adversely affect engine efficiency and emissions. Identifying this issue timely through diagnostics is vital for vehicle performance and compliance with emission standards. Several potential causes can trigger DTC P1188. A faulty FTT sensor can misrepresent the fuel temperature, sending high voltage signals to the PCM. Intermittent or poor electrical connections between the sensor and the PCM can also influence voltage readings, leading to this error code. Additionally, damaged wiring in the circuit, such as frayed or shorted wires, can cause unexpected voltages. It's also possible for the PCM itself to have issues, particularly if it has outdated software or is malfunctioning. Thoroughly investigating each of these areas will help in diagnosing the issue accurately and efficiently to ensure proper vehicle operation. The manifestation of DTC P1188 can lead to various symptoms affecting vehicle performance. One of the most noticeable symptoms is poor engine performance, which may present as hesitation or a decrease in acceleration. Additionally, drivers may experience increased fuel consumption due to the engine overcompensating for perceived fuel temperature variations. The check engine light will be illuminated on the dashboard to indicate an active diagnostic trouble code, prompting the need for further investigation. In some scenarios, the vehicle may also experience misfires, further compounding driving difficulties and potential damage to the engine if not diagnosed and repaired promptly. Recognizing these symptoms early can aid in avoiding more extensive mechanical issues. In the first step of troubleshooting DTC P1188, begin by turning the ignition switch to the on position, denoted as I. Next, verify the FTT sensor's data using the Honda Diagnostic System, HDS. You are looking for readings of approximately -40 degrees Fahrenheit, -40 degrees Celsius, or 4.92 volts or higher. If either condition is met, this indicates that the failure is duplicated, allowing you to proceed to step 2. Alternatively, if the readings fall within normal parameters, the vehicle may have an intermittent failure. In that scenario, closely inspect connections and terminals for the FTT sensor and the PCM to ensure they are not loose or corroded. Identifying these faults early can prevent further complications in the troubleshooting process. The next troubleshooting step involves turning the ignition switch to the lock position, denoted as 0. Afterward, disconnect the FTT sensor 2P connector to isolate the sensor from the circuit. Using a jumper wire, connect terminals A and B on the FTT sensor 2P connector. Terminal A is typically the LT green, light green, and terminal B is the black. Once the connections are made, turn the ignition switch to the on position again. Utilize the HDS to check the FTT sensor data once more. The goal is to verify if the data still shows readings of -40 degrees Fahrenheit or more than 4.92 volts. If these readings are observed, proceed to step 3. If not, replace the FTT sensor and move forward with the repair verification process. In this step, turn the ignition switch to the lock position to ensure all systems are off before further testing. After the ignition is off, carefully remove the jumper wire to return the circuit to normal. Now, turn the ignition switch to the on position to initiate the next phase of testing. At this juncture, it is essential to measure the voltage between two designated test points. The first test point is the LT green terminal of the FTT sensor 2P connector, and the second is body ground. With the FTT sensor 2P connector disconnected, the target voltage reading should be approximately 5.0 volts. If this is confirmed, proceed to step 4. If it does not measure correctly, move on to step 5 for further investigation. For step 4, turn the ignition switch to the lock position before starting the next phase. Jump the SCS service check signal line using the HDS to mitigate any potential faults. Disconnect the PCM connector A, which usually consists of 49 pins for proper troubleshooting. Next, using a jumper wire, connect terminal A, which is the BLK terminal of the FTT sensor 2P connector, to body ground. After this setup, check for continuity between test points 1 and 2, which are the BLK terminal at the PCM connector and body ground. If continuity is present, then the SG6 wire is confirmed as functional. If continuity fails, repair any detected open in the SG6 wire between the PCM A10 terminal and the FTT sensor before proceeding with further diagnostics. In step 5, as with the previous steps, begin by switching the ignition to the lock position. Once you have safely transitioned, jump the SCS line using the HDS again to prepare for testing. Disconnect the PCM connector A, as previously performed to ensure accurate diagnostics. This time, connect terminal A of the FTT sensor 2P connector, the LTGRN terminal, to body ground with another jumper wire. Check for continuity between test points 1 and 2, with test point 1 being the red terminal at the PCM connector A, 49P, and test point 2, body ground. A continuity check here validates the TF0 sensor and TF0 wire are operational. If continuity exists, ensure that the PCM software is updated. Otherwise, substitute a known good PCM and conduct repair verification. If continuity is lacking, repair the open circuit in the TF0 wire to restore function. The final repair verification process is a critical step to ensure that all faults have been resolved successfully. Begin by making sure that all connectors are reconnected securely, as any loose connections could interfere with proper functionality. Next, turn the ignition switch to the on position, signified as II, to enable the systems for testing. Utilizing the HDS, reset the PCM to clear any existing codes, including DTC P1188. After resetting, you must perform the PCM idle learn procedure as part of reintegration into normal vehicle operations. Finally, check for any pending or confirmed DTCs within the system using the HDS. If DTC P1188 reappears, scrutinize for potential loose terminals or connections at the FTT sensor and PCM. If no DTCs are present, then troubleshooting is considered complete. To prevent issues related to DTC P1188 from arising in the future, it is essential to perform regular maintenance checks. Periodically inspecting the FTT sensor for signs of wear or corrosion will help ensure accurate readings and proper engine management. Inspecting electrical connections for signs of looseness or damage is vital. This includes examining all wiring related to the FTT sensor and PCM. Taking proactive steps to maintain wiring integrity can prevent short circuits and high resistance that often lead to erroneous DTCs. Always keeping software up to date in the PCM can also mitigate unexpected errors by ensuring the latest calibrations are applied. Prevention plays a crucial role in maintaining vehicle performance and reliability. In conclusion, addressing DTC P1188 requires a systematic approach to diagnose and rectify the issues within the fuel temperature sensor circuit. Ensuring accurate sensor function is fundamental as it directly affects engine performance and fuel efficiency. Regular checks on electrical connections and wiring integrity can eliminate intermittent failures and high-voltage issues. Keeping the PCM updated prevents software-related discrepancies from triggering unnecessary error codes. As the troubleshooting process is followed diligently, it can lead to a successful resolution of the issue, restoring the vehicle's performance. By understanding the underlying causes and symptoms associated with DTC P1188, Honda Civic owners can take proactive steps in vehicle maintenance and ensure long-term reliability. Please like and subscribe to the channel. See you next time.